Are you building an ESP32 project and sick of all the button code? Well, I've built a library that you can just drop in to get clean events in minutes. Let me show you. Welcome to Little Man Builds. Now, for all you Arduino users out there, I don't use it specifically, but here's the quick way to access the library. You can go to the library manager and type in universal_button. Now, I've already got it installed and have tested it. Go across to examples, and there's 5 different examples to choose from. We'll select the basic button in this case. And what I particularly love about this library is that you simply define a button list. And so you can call this whatever you like. You can add another button called start, for instance, and put that on pin number, 25. And you can just keep adding as many buttons as you like. And as long as they're all listed before the universal button include, it will work. In one of the last coding videos, we built an RTOS template which we can run our project from. And if you haven't had the chance to check it out, I'll put the link up on the screen right now. The first thing we're going to need to do is include a new header which allows for fixed width integer types. Now we're going to go down here, change this to 100. Next thing we're going to add is our button settings. So debounce is to register a correct event and not some kind of interval between a 0 and a 1. So it allows for 50 milliseconds for the press event to actually be registered. The short press is 200 milliseconds and the long press is 1 second. Now, as per our Arduino environment, we also need to add a button list. So this is application-wide button mapping. And for the first example, we're just going to use test button 1. And so that should be correct. Now we should definitely have some errors in our main because we have changed our duration. So now we have no errors. We now need to add our universal button library. So head across into PlatformIO, into libraries, and you can search for universal button. By Little Man's Builds, we can add it to the project. And we click add. And it updates our platform.ini file with the library dependency of universal button. Great. Get out of here, and we can close our app config file. All we now need to do is include universal button. Now to make this work in our RTOS environment, we first need to add a pointer to some buttons, but it starts out as null pointer. Then we're going to add a global instance. So it's simply a global box called listener context where we'll store the button pointer and we can pass it to the listener task when we start it. So now we want to head down and we'll go to our startup and we can create a button timing configuration. We can call it kTiming and we can now pass our configuration variables from our app config file. So we can take firstly our button debounce milliseconds. We can then pass our short press duration and then our long press duration. Now we need to create the button, type button, and make the buttons using kTiming. And then we need to pass the address to our listener context. So we can go down into our listener task now, and we can add 2 lines at the top. So the first line says, treat this parameter as a pointer to the listener box. So basically get back my listener context box that I created for the task. And second line is grab the actual buttons from the box so I can use them directly. Now, we don't need this line. And instead, we now can say buttons.update because we always need to be updating the buttons. And then if buttons.isPressed, and this is the cool part of the library, we can call the button by its name directly. And we'll save that. And let's compile this and send it to the ESP32 and see if it works. By the way, if you're liking this content, feel free to smash the like button or consider subscribing. It helps the algorithm and I would love you to join our community. Most of the ESP32 development boards simply don't fit across a breadboard. There's usually only one line of GPIO pins that are accessible. So to fix this, what we can do is we can grab a knife and our breadboard and simply score down the outside. And this allows us to take off our power rail. Now, when I grab a second board, I can just join them together. Oops, wrong way. So now our ESP32 development board fits squarely in the middle with all our GPIO pins accessible. So let's give this a quick test. When I press the button, it says it's pressed. And when I let go, there's no input detected again. Perfect. That was a simple example. So let's take a quick look at the breadboard and see what's going on. Hooked up to GPIO number 6. Goes directly to the button to the opposite side and then back into ground. Now this orange cable indicates a 5-volt rail, which is to this pin here. And on my other side of the development board, I've got a red cable. So both this rail and my internal red rail on the board are both 3-volt 3 voltage rails. Let's add some more buttons to the mix. Another one here. And we need to pop this one to ground. We don't need this cable anymore. And let's add another button as well. Another one here. And put another cable here to ground. So there we go. So what's really cool about this library is that we can introduce a port expander. Now this is an MCP23017, and we use this because we may have run out of standard pins on our development board, and this gives us another, I think it's 16 different options, which is great. Now this board uses I2C communication, so it uses a serial clock line and a serial data transfer to move information backwards and forwards. With our ESP32, we can hook these up between pin 8 and 9. So I've got purple being data transfer and pin 9 being our clock. Pin 9 is our serial clock, which is here. And pin 8 is our data transfer. We then hook up to our 3-volt 3 rail and ground rail twice. I've got VCC and ground over here. And sadly, I don't have the correct color combinations for all these wires, but I can also do another one. So in this case, I'll just use orange and ground again. We have VCC, sorry, we have ground and we have VCC. So let's now hook up each of the buttons. The first one we'll use is A0. We'll go to here. Then we'll use A1, which is to here. And then finally, we'll use B0, second rail, on this side, and we'll also connect to this button here. So there's our hardware setup. We'll come back to this in a moment. Let's update the code. First thing we're going to do, let's go back to our libraries. And in this case, we're going to look for the MCP23017, so we can use the Adafruit library, add it to our project. And you can see now our platform.ini has been updated again. Get rid of this and this one. So let's briefly update this. Let's change this to 4. Call this test button 2. Put this on 5. 3, and put this in 6. Leave everything else the same. Go back into our main. So you can find all these examples online. So we're just going to speed through this one. I'm going to add button utils this time. We're going to include wire.h, which allows us to do I2C. And we're going to then add our Adafruit X7 library. I think in this case, I'm just going to do a big copy paste. So what we're doing now is we've added the I2C address. We've said that our MCP pins were A0, A1, and B0. We've added an assert just to ensure that the pins match the number of buttons. So in this case, there's 3 pins and there's 3 buttons. We've got our timing configuration up here. We've generated an object, and we have these 2 functions to read from the MCP, and we can have another one to configure the MCP pins. Instead of all this, we're going to add wire.begin. And then we want to configure the MCP pins. Now, I don't know why I did this, but I accidentally deleted this. We still need to pass our buttons to the listener context. So there we go. Now we can go into our listener task. Oops. And we're just going to replace this with this. So this comes directly from the example. Now I think we've got a naming issue because this in my app config was actually test button. Yeah, okay. Let's fix all these. All right, and let's see if this compiles. So again, it compiled just fine, which is great. So let's give it a quick test. We've got button 1, we'll do a quick press, so nothing's registered. Then we get a short press. And if I hold it down, I get a long press. Let's try our button 2. Short press and long press. Short press and long press. And if it's too short, it doesn't register at all. And that's because if we go back up here, you can see that our timing is different in this case. So I've done a debounce setting of 50 milliseconds, a short timing press of 300, and a long press of 1500. So 1.5 seconds for it to register a long press. So that's really cool. So there's a quick overview of the button library. It really has revolutionized my project, and I hope it does yours. If you've got any questions, leave a comment down below, but otherwise jump over to the Little Man Builds GitHub page and everything should be listed there. Of course, it would be really appreciated if you could like or subscribe. It definitely helps. And otherwise, catch you in the next one.